first thing you needed to do in order to find the sine, cosine, and tangent is you needed to find the leg. You had one of the legs in the hypotenuse. So you should have gotten 3 square root of 3 there for that. It was asking for exact values. And so then you would have just labeled it per the angle. So if you were looking at angle E, 6 would be the hypotenuse, 3 square root of 3 would be opposite, 3 would be adjacent. If you were looking at F, hypotenuse would of course still be 6, but opposite would be 3 and adjacent would be 3 square root of 3. And so you should have gotten, for E, and they didn't list the sine. The sine would have just been square root of 3 over 2. So I don't know where that is, but it cut it off. So for E, the sine of E would just be square root of 3 over 2. Cosine's 1/2, and tangent also got cut off. Just the square root of 3. For sine of F, 1/2, cosine of F square root of 3 over 2, and tangent of F square root of 3 over 3. For these last three, these last two, they gave you one of the trig functions. So in this case, they gave you cosine. So if they gave you cosine, then they gave you adjacent, and they gave you hypotenuse. And you would have used the Pythagorean theorem to solve for your opposite, and your opposite would have been 12. And so then you would have put opposite over hypotenuse for sine, and opposite over adjacent for tangent. For this next one, they gave you sine. So if they gave you sine, they gave you opposite over hypotenuse, and you had to solve for adjacent. Your adjacent side would have been 4, using Pythagorean theorem. Then you would have put for cosine, adjacent over hypotenuse, for tangent, opposite over adjacent. Solving right triangles. So we are going to use the opposite, adjacent, and hypotenuse to solve for sides and for angles that are missing in right triangles. This little paragraph here says almost any problem that involves indirect measurement of a distance or angle can be represented as a right triangle. Using the values of the basic trig functions enabled us to quickly determine the measure. And they give us this example of this lighthouse. The height of the lighthouse is known by the keeper. It says by sighting a ship and measuring the angle below the horizontal, the keeper can solve the triangle to determine the distance to the ship. So the height of the lighthouse is a known height, but this person that's in there does not know the distance to the ship. If they can measure the angle, so you can use a tool to measure the angle from the horizontal, you can actually create this right triangle here. So they can look at the angle measurement to this ship down here, and it creates this right triangle. So if you know the angle measure, here, and you know how high the lighthouse is, he can figure out how far away the ship is, right? And so they're just using right angle trigonometry to do that. And so we're going to start off with just basic triangles, and then we're going to get into word problems here. So the first thing we're going to do is just review a couple things that we did. The first thing is if you have a triangle like this one, and you are looking for the cosine of a specific angle, in this case, the cosine of that 30-degree angle, then the first thing we can do with right angle trigonometry is just label. We have a hypotenuse. This side is opposite of the 30-degree angle. This side is adjacent to the 30-degree angle. So if they want this measurement here, we could say that is the square root of 3 adjacent over hypotenuse 2. Square root of 3 over 2. Now, if it's not an angle that we have either a triangle for or something that is known, then you can use your calculator. And so if they want the tangent of 72, that's not an angle that we have a measurements for. We're just trying to find the ratio. We can plug that in to our calculator. And that's what we would do for both of these. We would say, well, we don't have a triangle with legs to measure. We just know the degrees, so we can use our calculator to calculate those ratios in decimal form. All right. So we're going to use this information with angles to then calculate other things. Let's look at this first triangle. It says solve the right triangle. So when it says solve the triangle, they want you to tell them every length of the sides, and they want to tell you every measure of the angles. All right. So typically when I solve a triangle, I'm going to say, well, angle A, angle B, angle C, what are those measures? And I'm going to fill in what I know. They gave me angle B is 72 degrees, and obviously C is my 90-degree angle. How do I figure out what angle A is? I'm going to take 90 and 72, and I am going to subtract those from 180, or you can actually just take the 72 from 90, because we know that those two have to be complementary. So if we do that, if we take 90 and subtract the 72, we're going to get 18 degrees. So that's our first answer, is angle A is 18 degrees. All right. The other thing they want is side length. So then I'm going to list out my side lengths. I'm going to list out side A, which is opposite of A, by the way, side B, and side C. They only gave me one side measure, which is 8. All right. So what I need to do is I need to use trig to figure out the other side lengths. All right. You can use trig to figure out one, and then you can use Pythagorean theorem to figure out the other. So if I am looking at this angle here, which is angle B, that's the angle they gave me, I am going to label the triangle based on the angle that they gave me. So C is going to be my hypotenuse. What is B? Opposite or adjacent? It's opposite to that one, and so this means this is adjacent. All right. So I want to solve for one of these sides. So what I'm going to do is I'm going to say, well, let's look at just the opposite side. The side I don't know here is the opposite side. I do know the adjacent side. Which of my 3 trig functions deals with opposite and adjacent? Sine, cosine, or tangent? Tangent. So I can say, well, the tangent of my angle, which is 72 degrees, should equal my opposite side, which I do not know, over my adjacent side, which I do know. All right. Now I have a basic problem. How do I solve for B? Algebraically, what do I need to do to solve for B? Yes, multiply the 8 over, right? So I'm going to take this and I'm going to multiply both sides by 8. It's going to cancel over here. So B, the side that I'm looking for, should equal 8 times the tangent of 72 degrees. So in your calculator, you're going to take 8 and multiply by the tangent of 72 degrees. When you do that, rounded to the nearest 1/10, you should get 24.6 centimeters. So B's length is 24.6 centimeters. So make sure that in your calculator you get 24.6. So for this last one, if we're solving for the hypotenuse, like the question was asked, can we just use Pythagorean theorem? Yes, you can. You have 2 sides of a right triangle. You can use Pythagorean theorem to solve for the third side. Or if you want to, you can use a trig function. The only problem with using a trig function is what you're solving for is on the bottom. So you're actually going to have to divide, not multiply. All right, so I'm going to show you both ways. So the first way is Pythagorean theorem. So c squared should equal a squared, which is your 8, plus b squared, which we just solved for. So we're going to take the square root of 8 squared plus 24.6 squared. And if you do that in your calculator, you should get approximately 25.9. All right. That is the first way to do it, is Pythagorean theorem. The other way to do it is to use another trig function, all right? I have hypotenuse and adjacent. And I would always go back to the one it gave me, not the one that I rounded. So I could use the cosine of 72 equals adjacent over hypotenuse. All right. Now, if what you're solving for is on bottom, you're going to end up dividing. The reason you do this is, of course, if you moved this h out of the way, you have h times the cosine of 72 equals 8. And then if you divide both sides by the cosine of 72, you will always end up dividing your side length by your trig function. But either way you do it, whether you do Pythagorean Theorem or whether you do 8 divided by the cosine of 72, you will get 25.9 centimeters. Once you have solved for all 3 sides and all 3 angles, you have solved the right triangle. That's what those instructions mean. When it says solve the right triangles, it wants you to give all 3 side lengths, all 3 angle measures. All right, and once you've done that, then you've solved the right triangle. You have the given information, and then you need to solve for what is not given so that all 3 of each have an answer. If sine of a equals x, then the measure of a is the inverse sine of x. So inverse functions work like anything else. Addition and subtraction are inverse functions. They pretty much cancel each other out. All right, so if you have the trig function and you need the angle, you can use the inverse trig function to find the angle. All right, on your calculators, it'll look like something sine to the -1, cosine to the -1, etc. It's usually the function right above your trig function. So if you look on your calculator, you should have sine, cosine, and tangent. Right above it, you should have sine to the -1, cosine to the -1, tangent to the -1. All right? To get to that, you're either going to use the second or the shift key, depending on your calculator. And so in this case, what we just did in that example is we had all the side lengths, or we had a side length and an angle, and we were finding a side length. In this case, we're going to have all the side lengths and we need the angle. All right? And so we're now solving for the angle. So anytime you're solving for an angle with trig, you're going to use your inverse functions. Anytime you're solving for the angle, use your inverse functions. Let's look at this first example. They want us to find the measure of angle A. So once again, the angle that they're talking about is going to determine how we label this. All right? So angle A is the one I'm talking about. They have given me 2 measures. I need to determine what side lengths those are. Hypotenuse is easy. Hypotenuse is the one opposite of the right angle. So then which side length is this 3 feet? Is it opposite or adjacent? It's opposite. So which of my trig functions, sine, cosine, or tangent, deals with opposite and hypotenuse? Sine, right? Remember SOHCAHTOA. Opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. All right? So the trig function that we're going to need to use is the one that deals with opposite and hypotenuse. It's going to be the sine. So we're going to say, well, the sine of A should equal my opposite over my hypotenuse. I want to solve for A. If the sine of A equals 3 over 5, then A should equal the inverse sine of 3 over 5. All right, and in your calculator, you're actually going to do a division, right? Your fraction line is just a division. So you're going to do it like that. All right, and so you need to try that in your calculator and make sure that you can put it in and that you are in degrees. And when you do that, you should get approximately 36.9. So A is going to equal approximately 36.9 degrees. Example 4 says solve the triangle. All right, so remember when we solve a triangle, we need to have all of the angle measurements. And we need to have all of the side lengths. And you can actually, I always label them across, but you can say the side lengths too if you want to. So I do this one as A, and this one is B, and this one is C, whatever's opposite the angle. So just make sure you know which ones you're talking about. All right. So they gave us A, they gave us B. And then obviously we know the angle measure for C. All right. So there's an easy way to find my third side length. What's an easy way to find my third side length? Pythagorean Theorem. So to find my side length for C, it's just the square root of the other two added together. All right. So that's easy. We can find that side length. All right. Now to find my angles. All right. You typically want to use the side lengths they gave you, not your rounded one that you just calculated with Pythagorean Theorem. So if I want to solve for A, I'm going to use the two sides they gave me. What is 17 based on what A is? Opposite or adjacent? It's opposite, which means B is adjacent. Which of my three trig functions deals with opposite and adjacent? Tangent. So the tangent of A should equal my opposite over my adjacent. So in my calculator, I'm going to say the inverse tangent of opposite divided by adjacent should equal A. All right. And when I do that, you should get approximately 57.1 degrees. Now I can do the same thing for B. What's another way to solve for B if I have two of the three angles? How else can I solve for B if I need that one as well? Subtract from what? Yeah, so 180 minus 90 minus 57.1. You can just subtract them from 180, and you should get 32.9 degrees there. All right. So when you're solving a right triangle, you may have to use trig once. You could use it a second time if you want to, or you can use adding up and use Pythagorean theorem as well. So the first thing I want to point out are the terms angle of elevation or angle of depression. These are all from the horizontal, all right? So if you are looking straight ahead, that is the horizontal. The angle of depression is the angle down from that. The angle of elevation is the angle up from that. And so perspective is very important when you are doing these word problems to figure out what you're talking about and whether the object is below or above the line of sight. All right? So let's look at the first example. Page 585, example 5. A survey team flying an altitude of 7,000 feet measures a 7.5 degree angle of depression to the summit of Mount Mitchell. After flying another 2,400 feet, they are directly above the summit. How high is Mount Mitchell? All right, so a couple things that I want to point out here with this one is we have kind of extra measurements here to begin with. They've given us this 7,000 feet, and we actually don't need it right now. We're going to need it at the end of this problem. So when you're reading your word problems, make sure you pay attention to what they've given you and what you need to solve. All right? So we know that they are at an altitude of 7,000 feet, which is important at the end, right? They fly 2,400 feet. So this is a horizontal measurement here, 2,400. And it tells us they're directly above the peak of the mountain. This 7.5 degrees is to the peak there of the mountain. So the right triangle that is created is actually this one. And we don't use the 7,000 at all for the right triangle. If we need to figure out how tall the mountain is, we need this little piece so that we can subtract it from the 7,000 at the end. All right? So we are going to look at this right triangle, and we are going to do the opposite adjacent hypotenuse information based on this right triangle right here. And so my angle of depression, that means from the line of sight in the airplane down. All right? So the angle of depression is the 7.5 down. The 2,400 is the horizontal distance over. We are looking for how far above the peak they are. So I'm going to look at just these two sides. Based on this 7.5, which side is this? Opposite, adjacent, or hypotenuse? What is x? It's opposite. What about the 2,400? Opposite, adjacent, or hypotenuse? This is adjacent. So which of my three trig functions deals with opposite and adjacent? Tangent. So the tangent 7.5 should equal my opposite x over my adjacent 2,400. So to solve, I'm going to do just like I did at the beginning. I'm going to multiply both sides by the 2,400. And so x should equal 2,400 times the tangent of 7.5 degrees, which is approximately 316 feet when you do that in your calculator. All right? What did that tell me? That told me how far above they were from the peak. What is the question asking? How tall is the actual mountain? So I have figured out this little distance. We know the total distance. We want the height of the mountain. So this is when the 7,000 comes into play. Here, I'm going to take that 7,000. I'm going to subtract how far above they are from that, and then I'm going to get the approximate height of that peak. So make sure you know what you're looking for and when you need what you need. All right? So that's an angle of depression. All right? Let's look at the next problem, example 6, and then we're going to do a word problem. This is another place where this is used. This is used all the time for surveying. A surveyor must find the distance between two posts, A and B. They are on opposite sides of the river. After placing a post directly across from B at C, she walks down the stream along the bank, perpendicular to the line, and measures AC. She also measures the angle from A to B. All right, so what she's done here is she's done something that's perpendicular. She knows she has a right angle here, and then she walks along here 180 meters. She also knows the angle measure here. She's used a tool to find the angle measure. What she needs is the distance between these two. All right, she needs the actual distance. So I am going to use the angle measure that I know of 43 degrees, and I'm going to label the sides that I'm trying to use. In this case, I need to find this side right here, and I have been given this side. So based on this right triangle, my x is going to be which side? Opposite, adjacent, or hypotenuse? Hypotenuse. What about the 180 compared to the angle A? Is it opposite or adjacent? Adjacent. Which of my three trig functions deals with adjacent and hypotenuse? Cosine. So the cosine of 43 degrees should equal my adjacent 180 over my hypotenuse, x. Now remember I said anytime what you're solving for is on bottom, you are going to divide, all right? If it's on top, you're going to multiply the two numbers. If it's on bottom, you will divide. You will always be dividing by your trig function if your variable is in the denominator. So my variable is going to equal my numerator 180 divided by my trig function there. All right, divided by my trig function. And when you do that, you should get approximately 246 meters, which means these 2 points are approximately 246 meters apart. All right, let's try one. Turn to page 586. 586. You're going to do one almost identical to the one we just did, number 13. So label your triangle and then find the distance they're asking for.